Today, we're going to get into the engineering behind the next huge leap in wireless, Wi-Fi 7. Now, its official name is IEEE 802.11b, and it was built from the ground up for one thing and one thing only, extreme performance. So let's break down what that really means for our networks.
All right, before we jump in, just a quick note that this is part of a much larger series. All the info we're covering comes from a super detailed report for IT professionals by the RFI Detectives, who are part of Virtualization Options LLC. And today, we're focusing on their analysis of the game-changing Wi-Fi 7 standard. So you might be asking, why now? I mean, we're still rolling out Wi-Fi 6 and 6E. What's the big rush? Well, it turns out we're hitting a brand new kind of performance wall, and it's being driven by applications that honestly felt like science fiction just a few years back.
And this really leads to a critical question for every network architect listening. Is your current setup really ready for what's just around the corner? Because what's coming next isn't just a small step up, it's a fundamental change in what we expect wireless to do for us.
And just look at the kinds of things pushing the limits. We're not just talking about more bandwidth here. Stuff like high-res XR and industrial automation, they need ultra-low, and this is the key, deterministic latency. That means it has to be predictably fast, every single time. Cloud gaming needs a connection that feels instantaneous, and streaming, we're already moving past 4K to 8K. These apps don't just strain an outrock, they pretty much break the rules that older standards were built on.
And that is exactly where Wi-Fi 7 comes into the picture. It wasn't just designed to be a little bit faster. Nope, it's a direct engineering answer to those very specific high-stakes challenges. So let's take a look at what makes it so incredibly different. Okay, first things first, a really important clarification. Wi-Fi 7 is IEEE 802.11b. That's 802.11be. You absolutely cannot get this confused with the ancient 802.11 standard from way back in 1999. I mean, we are talking about a difference between 11 megabits per second and a theoretical 46 gigabits per second. They're just not in the same universe.
This really gets to the core mission. The source material couldn't be clearer here. The design mandate for 802.11b was to deliver two things. First, extreme throughput, that's the raw massive speed. And second, ultra-low deterministic latency. In other words, not just fast, but reliably and predictably fast every single time. And that's the real game changer for anything happening in real time. So how does it actually pull this off? Well, it's not just one magic bullet, it's a combination of several huge technological steps forward, all working together. Let's break down the core ingredients. The entire foundation of Wi-Fi 7's power is the 6 gigahertz spectrum. This was first opened up with Wi-Fi 6E. The best way to think about it is like a brand new multi-lane superhighway that has zero old, slow traffic on it. This clean, wide-open airspace is what makes all the other cool stuff possible. Now, building on top of that new spectrum, Wi-Fi 7 basically doubles the size of the road. We go from 160 megahertz channels in Wi-Fi 6E to absolutely massive 320 megahertz channels. It's pretty simple, really. If your data pipeline is twice as wide, you can move twice as much data through it at the same time. Next up, we get way more efficient with the data we're actually sending. A technology called 4096 QAM lets us pack 12 bits of data into each signal, up from 10 bits in Wi-Fi 6. That's a straight-up 20% boost in efficiency. But the catch is, you can only pack data that densely if you have a super high-quality clean signal, which is exactly what that 6 gigahertz band gives us. And when you combine those super wide channels with this denser way of packing in data, you arrive at this incredible headline number, a theoretical max speed of 46 gigabits per second. That kind of speed completely redefines what we thought was possible over a wireless network.
Okay, so having those amazing specs is one thing, but as IT professionals, we have to think about strategy. How does this fit into the bigger picture of networking, and what does it actually mean for our future deployment plans?
This table really puts the jump into perspective. I mean, look at the evolution here. The jump from Wi-Fi 4 to 5, and then to 6. Those were all big, important steps. But the jump from Wi-Fi 6's 9.6 gigabits per second to Wi-Fi 7's 46 gigabits per second, that's nearly a 5-fold increase. It is by far the single biggest performance leap in the history of Wi-Fi. But here's the crucial takeaway for architects. All this new power demands a totally new security posture. The RFI Detectives report lays out some clear marching orders. WPA3 is no longer optional. It's the absolute baseline. We have to start planning for post-quantum cryptography, encryption strong enough for the future.
And with the explosion of devices this speed will allow, you have to be rigorous about segmentation. You have to remember, zero trust doesn't start in the cloud, it starts right at the radio waves.
And so we come full circle, right back to this core principle. Every single feature we just discussed, the wide channels, the advanced modulation, the clean spectrum, it all serves this one unambiguous purpose. Wi-Fi 7 is the tool that was specifically engineered to finally solve that dual challenge of throughput and latency. So, we're left with this one final thought. The speed is coming. It's going to enable some truly incredible things. But with that kind of power comes a whole new level of responsibility. The real question isn't if you'll adopt Wi-Fi 7, but how you're going to architect your network to handle the brand new security landscape it creates.